In July 1958, the New York Times reported that the United States Navy had built the embryo of a machine that would soon walk, talk, see, write, reproduce itself, and be conscious of its own existence. The machine was called the Perceptron. What it could actually do was tell the difference between a card marked on the left and a card marked on the right. That gap between what was announced and what was in the room is the oldest story in artificial intelligence, and it has repeated, almost on schedule, for 70 years. The field was named in the summer of 1956 at a workshop in Dartmouth College. The proposal that got it funded is a remarkable document. It claimed that a 10-man study over 2 months could make a significant advance on machines that use language, form abstractions, and solve the kinds of problems then reserved for human beings. They were not being cynical. They believed it. In 1965, Herbert Simon, who would later win a Nobel Prize, wrote that machines would be capable, within 20 years, of doing any work a man can do. In 1970, Marvin Minsky told Life magazine that in 3 to 8 years we would have a machine with the general intelligence of an average human being. What arrived instead was arithmetic. Machine translation, the great early promise, turned out to require understanding the world, not just swapping dictionaries. In 1966, an American government report concluded that translation by machine was slower, less accurate, and more expensive than translation by people. The funding stopped. Britain went next. In 1973, a report by the mathematician James Lytle found that the field's methods worked beautifully on toy problems and fell apart on real ones because the number of possibilities to search exploded as problems grew. British AI funding was cut almost to nothing. This is the period researchers now call the first AI winter, and the name is telling. Not a failure, as in something you wait out. It thawed in the early 1980s, and the second boom looked much more serious than the first because this time there were customers. The idea was the expert system, capture what a specialist knows as a very large pile of rules and let the machine apply them. It worked. A system called XCON, which configured computer orders for the Digital Equipment Corporation, was saving the company tens of millions of dollars a year. Japan announced a national project to build the next generation of intelligent machines and put hundreds of millions of dollars behind it. Corporations bought specialized computers designed to run nothing but artificial intelligence. Then, in 1987, the hardware market collapsed in a single year. Ordinary workstations had become fast enough to do the same job for a fraction of the price. The expert systems themselves aged badly because every rule had to be written and maintained by a human being, and the piles grew until nobody could keep them consistent. The second winter set in. So why does this keep happening? 2 reasons, and they are still with us. The first is that demonstrations scale badly. Getting a system to work impressively once in a lab on a curated example is a fundamentally different engineering problem from getting it to work reliably everywhere on inputs nobody anticipated. Almost all of the cost lies in that second half, and almost none of the excitement does. The second is stranger. Every time artificial intelligence genuinely succeeds, we stop calling it artificial intelligence. Optical character recognition, chess, spam filtering, route planning, speech transcription, all of these were AI problems until they were solved, at which point they became ordinary software. The computer scientist Larry Tesler put it best. Intelligence, he said, is whatever machines haven't done yet. The field is defined by its unsolved remainder, which means it can never be seen to have won. Which brings us to now. There are real reasons to think this boom is different. The systems are not handwritten rules, they learn from data. They are not confined to laboratories, they are deployed at enormous scale to hundreds of millions of people. And unlike 1973 and 1987, there is revenue. Money is coming back out, not just going in. But some things have not changed at all. The most confident predictions still come from the people raising the money. The timelines are still suspiciously round numbers, and the gap between the demonstration and the deployment is still where the difficulty lies. The lesson of the winters is not that artificial intelligence does not work. It is that it works more slowly than its promoters promise, and more thoroughly than its critics expect. The Perceptron never became conscious of its own existence. But the thing it actually started, machines that learn to recognize patterns from examples rather than from rules, is now in the phone in your pocket. It just took 70 years instead of 20.